Hello, my name is Shanae Thomas, and I will be conducting a presentation on linear regression using PSPP. This is for the GRC 605 Business Research Methodology and Quantitative Stats course. The agenda for this presentation is to explain the results of the linear regression tests that were both significant and not significant using the APA format. I will also provide an annotated bibliography of articles I found important during the course and explain why I thought the articles were helpful. Then I will discuss the takeaways and provide time for any questions. Linear regression is used to determine the extent to which there is a linear relationship between a dependent variable and one or more independent variables. In the following examples, I want you to keep in mind that the rejection rule for them is that we reject the null hypothesis when p is less than alpha and alpha is equal to 0.05, and we fail to reject the null hypothesis when p is greater than alpha. The confirmation rule is that 0 is not within the 95% confidence interval. And confidence interval for means are intervals constructed using a procedure that will contain the population mean a specified proportion of the time. In this example, there was no significant result found between debt and income. The following regression was conducted. The null hypothesis was the regression coefficient is 0, and the alternative hypothesis was the regression coefficient is non-zero. A simple linear regression was conducted to determine whether debt could be predicted from income. No significant regression was found. Beta was equal to negative 0.05, r squared was equal to 0.00, and p was equal to 0.535. Being that the p-value was extremely bigger than 0.05, we failed to reject the null hypothesis. In this example, a significant result was found between savings and income. The following regression was conducted. The null hypothesis was the regression coefficient is 0. The alternative hypothesis was the regression coefficient is non-zero. A simple linear regression was conducted to determine whether savings could be predicted from income. A statistically significant regression emerged, where beta was equal to 0.91, r squared was equal to 0.82, and p was equal to 0.000. Thus, the test rejected the null hypothesis and predicted savings and income. Savings and income equal 0.91 times income plus 0.00. Savings and income is predicted to decrease as income increases. Further, the 95% confidence interval of 0.09 and 0.11 does not contain 0, hence lending support to the prediction. In this example, a significant result was found between stocks and savings. The following regression was conducted. The null hypothesis was the regression coefficient is 0, and the alternative hypothesis was the regression coefficient is non-zero. A simple linear regression was conducted to determine whether stocks could be predicted from savings. A statistically significant regression emerged where beta was equal to 0.28, r squared was equal to 0.07, and p was equal to 0.000. Thus, the test rejected the null hypothesis and predicted stocks and savings. Stocks and savings equal 0.28 times savings plus 0.00. Stocks and savings is predicted to decrease as savings increases. Further, the 95% confidence interval of 0.07 and 0.25 does not contain 0, hence lending support to the prediction. Okay, one of the articles for the annotated bibliography came from the Handbook of Biological Statistics. In this article, it reflected on the importance of p-values and how one of the main goals of hypothesis testing is to estimate the p-value. It went into detail regarding the null and alternative hypothesis. The null hypothesis is a statement that you want to test. In general, the null hypothesis is that things are the same as each other, or the same as a theoretical expectation. The alternative hypothesis is that things are different from each other, or different from a theoretical expectation. If the p-value is less than 0.05, you reject the null hypothesis. If p is greater than or equal to 0.05, you don't reject the null hypothesis. This article set the tone for the class, as this class dealt with p-values, null hypothesis, and alternative hypothesis throughout its entirety. In this article, from the Research Methods for Business, a skill building approach, it elaborated on the importance of how certain types of questions can be understood by the respondents. There are 3 focus areas that questionnaire design principles focus on. These areas deal with the wording of the question, the planning of issues with regard to how the variables will be categorized, scaled, and coded after receipt of the responses, and the general appearance of the questionnaire. They all minimize data. There are ways that questions should be presented because it essentially depends on if it is a good or bad question and will determine the results of the survey. In this article from the Handbook of Biological Statistics, it discussed the importance of the chi-square test of independence. It should be used to determine whether there is a significant association between the 2 variables. The null hypothesis for the chi-square test is that the relative proportions of one variable are independent of the second variable. In other words, the proportions at one variable are the same for different values of the second variable. These articles were extremely helpful to me throughout the class. I chose the previous articles that I discussed because they all were extremely useful to me, being that I have not taken a stats course in a while. The articles were very detailed and provided a multitude of information. They all related to each other in one way or another. The null and alternative hypothesis, p-value, questionnaires, and chi-square test of independence were all vital to me in grasping the concept of the particular lessons. I gained a better understanding through the readings provided to me in the course. There were also a few important takeaways from the lesson. You can perform linear regression tests using PSPP as I described in the previous slides. Make sure to get the coefficient confidence intervals in R when conducting linear regressions. Also, if confidence interval is within 0, then you likely do not have a significant regression. Does anyone have any questions for me? I would like to thank you for taking the time out to listen to my presentation. Thank you. Bye.